Both are one and the same, right, sir? Biogeochemical cycle and nutrient recycling or nutrient cycling. How it is happening, sir? So nutrients, in the very first class I told, we have it in soil in the form of minerals. So mineral is the source of the nutrient, right, sir? So the plants derive the nutrients from minerals present in the soil, right, sir? This minerals is converted as a biomass. Okay, we are gaining weight because of consuming these minerals, because of consuming these nutrients. So from where, what are the source of these nutrients, sir? From where the nutrients are derived? So it is called as biogeochemical cycle. That is, it is going to get transferred between the earth and the organisms. These things we made clear earlier, sir. You are nothing but what is your soil. I explained it, right, sir? We are nothing but what is the mineral present in the soil is the makeup of my body. So what is the mineral present? That will be present in the plant as a plant product, final product that we are going to consume. So how this is being cycled in the earth surface? Say nitrogen, that is very, very, so we need, what else we need, sir? What we need for our day-to-day activity? We need carbohydrate. Okay, as a food source, carbohydrate, protein, and fat. These are the food derivatives what we expect, right? Carbohydrate, protein, and fat. Let me elaborate these things, sir. So can someone tell the very easiest way to tell what is a carbohydrate? These are the food things, these are the substances present in the food, what we consume. Either we will consume something as carbohydrate. So I'm eating idli. The idli is derived from what, sir? Paddy. The paddy is nothing but a source of carbohydrate, right? So carbohydrate derivative. Or else we will take some pulses, or else some meat. They are nothing but some source of proteins. And fat, ghee, milk products. Okay, even some animal derivatives, they are fat products. So these are the only food supplements what we take in massive scale. From where this originated, sir? We will take this example of carbohydrates. So carbohydrate, Tamil solla maavu chattu. Okay, if I grind a paddy or else a cereal, I will get what you call this, sir? Carbohydrate, maavu chattu kadaikum. So if I'm analyzing the ingredients present in this paddy, okay, at the minuscule level, it will be nothing but carbon, hydrogen, and oxygen in some proportion, right, sir? If I have simply some carbon, hydrogen, and oxygen in a food product, it is nothing but carbohydrate source. Rice is a source of carbohydrate. So how these carbohydrates are being accumulated in rice? That is the question here. This gives the sense of biogeochemical cycle. So what is the source of carbon, sir? From where you can get carbon? Someone, sir. Sir, understanding this gives a clear picture. What is carbohydrate? Simply you are telling what is, we are speaking about carbohydrate source, that food sources rich in carbohydrate. One particular food source is rich in protein. One particular food source is rich in fat. What are these substances, sir? What these are made up of? So if you analyze deeper in a physiological, in a psychological way, joined with scientific manner, we will get a clear answer. Carbohydrates, carbon, it is present in the atmosphere, right, sir? Hydrogen, it is present in atmosphere. Oxygen, it is present in atmosphere. So in a rice grain, see a rice grain, it is nothing but carbohydrate content. Again, if I analyze this, I can separate carbon, hydrogen, and oxygen, which is present in the atmosphere, or else from the soil source. Carbon can be derived from soil source even. Okay, so some gases, the plants are utilizing these gases or minerals, and they are storing it. So can you imagine, sir, rice is nothing but a gas. If it is told in a more philosophical manner. Are you getting me what I'm speaking, sir? If I do analysis, what is a carbohydrate is? At last, it is nothing but some gases in particular composition. So this plant, out of photosynthesis, using sunlight, they are deriving what's a carbon dioxide. They will fix that. Okay, some nutrients from the root, they will enter into the plant as a final product. So carbohydrates, that is nothing but carbon, nitrogen, oxygen, and protein, when nitrogen or sulfur gets attached with these carbohydrates, it becomes a protein. Understand, sir? How the food sources is being transformed from one form to another form. From carbohydrate, that is a simple level of food source. When nitrogen and sulfur, nitrogen or sulfur is getting attached to this molecule, it will get converted as a protein. So nitrogen, where it is, atmosphere has 78% of nitrogen. Can the plant derive the nitrogen directly? This nitrogen molecule present in the atmosphere, they are present in N triple bond N, which needs highest level of energy to break this. So this nitrogen present in the atmosphere, they are not readily reactive. They are not readily available to the plant. Are you getting me, sir? So this is in our unavailable form. The nitrogen present in the atmosphere, it is in unavailable form. There are some microorganisms which will convert this unavailable nitrogen, which has the capacity to break this N triple bond N. They are called as atmospheric nitrogen fixers. Okay, so rhizobium, rhizosphere, rhizo means root. So rhizobium is a bacteria, microbe, which has the capacity to make available the unavailable nitrogen to plant available form. So by this way, say if I'm getting a protein source, say a pulse crop, any piece or anything, pulses. So they will derive the atmospheric nitrogen, okay, through some microbes. They will transform the nitrogen present in the atmosphere and they will make available to the plant. By this way, protein is formed. So carbohydrate is the main building block of anything. So our body even has more of carbohydrate, but we need protein for excessive work, right, sir? Normally, those who are doing heavy workout, they will be needing excessive proteins, right, sir? So these organisms, simply these microorganisms, are having the potential to convert this unavailable form of nitrogen to available form. These are called as atmospheric nitrogen fixers. Nitrification process, right, sir? That's why if we see some groundnut, if you plug a groundnut with the root, if you plug a pulse crop with the root, you can see some nodules present in the roots. Have you ever seen, sir? Some nodules will be present. If you crush that nodules, you can find blood color ooze out. Some red color ooze out will come. Some pinkish red ooze out will come from these root nodules. These are called as nodules. Right, sir? These are called as leg hemoglobin. Since they are associated with the leguminous crop means pulse crop, which is the protein source. They are called as leg hemoglobin. As like our blood, they also appear red in color. Right, sir? So imagine, sir, a single cell organism, a microorganism that is having a potential to break this N triple bond N and converting the unavailable nitrogen to a plant available form of nitrogen and enhancing protein production. Whether this N breakup takes place naturally, sir. If you notice, whenever there is rainfall, after rainfall, all of the vegetation, let it be any plant or tree, they will be very much greenish color. You can see that it will be more of greenish color after rainfall. Even there was a question in UPSC once, some 7 or 8 years back, just after rainfall, the leaves of the trees are appearing green. What is the reason associated with this? So the options given were, after rainfall, the rainwater will wash away the dust particles present in the leaf. Right, sir? But the actual science is, when lightning is happening, can you imagine the amount of energy released during lightning? If a lightning falls on the earth, on the tree even, the tree will catch us fire during rainfall itself. At the time of rainfall even, when the lightning is reaching the earth's surface, it will burns anything, it will breaks anything. Even if the lightning is falling in the aquatic ecosystem, it will kills all of the organism present in the aquatic ecosystem. That is the level of energy present in a lightning activity. So this much amount of energy will break this N triple bond N. Now the two molecules of nitrogen are no more associated. They are free nitrogen now. Along with water, they will get dissolved. So the rainwater will be having more of nitrogen now, and they are available to all of the plants and trees because nitrogen is the primary nutrients for all of the plants. Okay, so the primary nutrients are NPK, nitrogen, phosphorus, and potassium. So these are the major nutrients or primary nutrients required for any of the vegetation. So the nitrogen source for a plant is assured whenever there is rainfall. That's why it means that more of food is being given to the tree. It's fed directly to the tree. There is a kind of action taking place after rainfall, at the time of rainfall, during the action of, by the action of lightning. So imagine how much of energy is required to break this N triple bond N. So even we are preparing nitrogenous fertilizer in artificial manner through Haber's process, right, sir? Through Haber's process. So for this Haber's process to happen, we will supply more of artificial energy, electricity, okay, in a furnace, in a clean, okay, nitrogen molecules are broken up. We can't even imagine the temperature. More amount of temperature, energy source is required for Haber's process for production of N fertilizers, nitrogenous fertilizers. But this voluminous action, this risky task, this more energy consuming activity is made by a small bacteria that is rhizobium. Then who is powerful, sir? Imagine the power of a microorganism. That is what we are witnessing in a drastic manner out of corona now, right, sir? So microbes, they are very, very powerful in various activity. We can tell a number of examples. Okay. So rhizobium, nostack, anabanna, blue-green algae, these are all examples of atmospheric nitrogen fixation. So biogeochemicals, by one way or another, the nutrients present in earth or else in the atmosphere, they will come to a plant. They have to enter into a plant and we have to eat it. After the animal consume it, the animal will die. And again, after its decomposition, the animal will supply the nutrients or minerals. After decomposition, again, it is recycled in the earth. Again, consumed by the plant. Again, consumed by we people. By this way, the cycle will continue. Right, sir? Nutrients present in the soil, it is transferred to some other producer, then to consumer, finally to earth, again decomposed, again utilized by the plant. In this way, the cycle will continue. Understand, sir? So in soil, it is present, it is utilized. One such example I told is nitrogen fixation. It is utilized by the plant. The plant will produce, the plant means the plant, entire body of the plant is having all of the minerals present in the soil. When an animal, say a human being is consuming or else an animal is consuming, we are deriving the mineral source from the plant. All animals and human beings. Okay, sir. When this will die, they will get decomposed. After death, they will get decomposed. Again, whatever minerals present in my body after my birth, death, decomposition is taking place. The minerals will be again utilized by the soil, taken by the plant. This cycle will continue. Right, sir? So now we will make this thing also clear, sir. So protein part is completed. When nitrogen or sulfur is added, then carbohydrate will get transformed as a protein. Where is the sulfur source? So nitrogen is present in the atmosphere, carbon present in, sir, but we are consuming leaves like spinach, whether the energy we get may be 70%. So I can't tell 70%, sir. We have to consume more of the leaves. That's why single leaf will not suffice. Suffice me. Accumulation is needed. I have to consume more of the things to derive more of energy. Right, sir? So come to this point, what is fat? When the proportion of the carbohydrate, when the proportion of carbon, hydrogen and oxygen is getting altered, when it is changed, maybe it's some 3 carbon, some 6 hydrogen. So when the proportion is getting altered, it will become a fat. So at last, whatever the minerals or nutrients present in the soil and atmosphere, that is nothing but the food constituent. This understanding is needed. Sulfur, it is sulfur or phosphorus, they are attached with rocks. Phosphorus, they are present attached with the rocks. So whenever the rock is getting disintegrated, then only it will get released. Whereas it is very easy. Nitrogen, it is present in the atmosphere. So whenever there is lightning, the plant can utilize. Oxygen, it is present in the atmosphere. Plant can utilize that. And this cycle will continue and it will make a complete cycle within some short time period. That is gaseous cycle, what I'm speaking. Right, sir? So gaseous cycle, the utilization and the gaseous cycle. The utilization, I'm utilizing that gaseous cycle. The utilization of carbon, hydrogen, oxygen, nitrogen, and the replenishment ratio. How it is getting replenished. This ratio of consumption and replenishment is faster. That's why it is called as perfect cycle. Have this in mind. All of the gaseous cycle are called as perfect cycle. Whereas these phosphorus or sulfur, okay, they are attached with any rocks or any, they are present, trapped in some substances. Okay, sir. That's why it is called as imperfect cycle. The recycling time period is higher. So sulfur cycle, phosphorus cycle, they are called as imperfect cycle based on its time cycle, time period for its replenishment and compared with utility. Understand, sir? And we discussed succession has been finished. Now we'll get into a new topic, that is aquatic ecosystem, sir. So what is an aquatic ecosystem? Which is having water simply, right, sir? Which is dominated by water. So yesterday we even classified aquatic ecosystem based on its flowability. If it is flowing, it is called as lotic. L-O-T-I-C, lotic. If it is stagnant, it is called as lentic, right, sir? Anand Jawahar, I will come to your point in a clear manner while discussing later slides, sir. We will finish this. I have given a hint about your question, but we'll make it clear in coming discussion. So aquatic ecosystem can be classified. If it is flowing, it is lotic. If it is stagnant, it is called as lentic. Again, there is one more criteria to classify it based on its dissolved salt. When the dissolved salt level is 5 or less than 5, it is fresh water. When it is between 5 to 35, it is called as marine water. Sorry, it is brackish water. 35 ppt, parts per thousand. Right, sir? It becomes brackish. When the range of dissolved salt is above 35 or 35 and above, it will become marine ecosystem, right, sir? So this is the classification. Now we'll see what is the type of organism, how to classify the organism present in an aquatic ecosystem. Right, sir? How do I classify, sir? So there are 5 categories, 5 ways to classify, 5 names are associated in classifying the organisms present in an aquatic ecosystem. Before this, we will see the zonation. See, this is the terrestrial area, right? This is the water body. The place where it is meeting the terrestrial area is called as littoral zone. Right, sir? Somewhat shallow zone. You see, the depth of water is very shallow, very minimal here. This zone is called as littoral zone. So otherwise it is a shallow zone whenever a water body meets a terrestrial area. Even this is common for a marine ecosystem, a swampy area or anything, a mangrove forest. Whenever a water body meets a land mass, the shallow zone is called as, the meeting point is called as littoral zone. Whereas limantic zone, this is the entire open aquatic ecosystem. This area, you can't find soil here. It is very deeper area. Right, sir? So I can tell the open area which is facing the sunlight is called as limantic zone. The vast area occupied by an aquatic ecosystem which is facing the sunlight, that is called as limantic zone. Right, sir? Then one more thing, benthos. The lowermost area is called as benthic zone. The bottommost area of aquatic ecosystem is called as benthos. If it is a marine ecosystem, then you will call it as abyssal plain, right, sir? The lowermost area, but the deepermost area in a marine ecosystem will be deep sea trenches, but the vast plain area is called as abyssal plain if it is a marine ecosystem. Here I have given something as pond ecosystem. So I am doing a comparison. Abyssal plain, that is for sea or ocean, marine ecosystem, right, sir? But here it is nothing but benthos, a pond or lake ecosystem. It is benthic zone. So we'll go one by one. So Newston is the type of organism, first type of organism. See this one, periphyton, that is the second type of organism. And zooplankton and phytoplankton, third type of organism. Fourth is nekton, type of organism. And finally benthos. Right, sir? These are any organism it may be. We can classify the organism, aquatic organism, under this criteria. What is anemonas? I look into that, sir. I look into that. We will finish this. So this, you will get questions about the feature of this organism. I am classifying the aquatic organisms based on the zonation, based on which depth they are present, in which area the organisms are confined. Newston, that is the topmost organism. These organisms are present in the topmost layer of the aquatic layer. See the topmost surface. Okay, so they will be floating. They will be found floating on the, what's that? Open area. Not only open area, even in littoral zone. That is in the topmost layer of the aquatic ecosystem. If I find some organism floating over that, we can call it as Newston. See, if you have seen in villages, if you have gone for a pond, you can see some smaller beetles floating over the, what's that? Floating over the water, floating upon the water. So water beetle. Okay, sir. Backstriders. Water beetles, backstriders. These are some insects, sir. Nothing but some insects. Backstriders or back swimmers. So always there will be floating over the topmost layer of the water. Okay, sir. Backstriders. These organisms are present. They never ever go inside this aquatic ecosystem. They will be always floating. How it is possible for the beetle not to get sinked into the water? Their adaptation, their modification of the body will be such that their limbs, there is the legs, the limbs will be having that much adaptation. It will be having some, as like a waxy coating, it will be having some waxy coating, so that the water will not get inside their body and always they'll be floating. Even if you see some lily flower, if you look into the lily leaf, at the underneath area and even the upper surface, you can find some waxy coating, so that there is no chance that they won't sink. So Newston organisms are the topmost organisms, or organisms which are living in the topmost layer of the aquatic ecosystem. I can even tell that they are present between air and water interface, the place where water and air meets. See here, this is the topmost layer and air is meeting here. So air-water interface. This is the key word, sir. So organisms which are found in air-water interface are called as DAS. Right, sir? Air-water interface. So they are not completely present in water, but they are facing the atmosphere. They are facing the air. So organisms which are present in air-water interface are called as neuston, or else simply I can call it as a floating organisms. Some examples are water beetles, backstriders. Okay, they swim in a backward movement. They move in a backward movement, backstriders, right? So next one is periphyton. What is python, sir? Python. It is nothing but plant. Phytology, the study of plant is called as phytology. Then what about pycology? Yesterday we told something about pycology, pycobient. So minor difference. Pyco, Pycology. Pycology means it is nothing but study of algae. The algal partner in a lichen is called as pycobient. Study of algae is pycology. Study of plant is called as phytology. Here the word comes periphyton. So something which is dealing with the plant. Peri means periphery. Periphery means at the edges. So organisms which are growing at the edges of the plant, the plants will be submerged in condition. That is the criteria. So organism, see here, they have enlarged here at the periphery of this leaf floating plant. Okay, at the edges, they are growing attached to the clinging upon. Clinging means holding. These organisms always hold the plants, submerged plants, clinging. The clue word here is clinging upon. Submerged organism growing submerged manner at the periphery of the plant in a clinging fashion. Clinging means in an attached fashion. These are called as periphytons. Since they are present in the periphery, at the edges, they won't prefer to grow at the central part of the plant. They will try to grow at the edges, periphery. So periphytons are organisms growing clinging upon. And next one, they are the heroes, zooplankton and phytoplankton. So among these, who are the producers, sir? So plankton means nothing but an algae, right, sir? The other term for algae is plankton. So in this algae, who are the producers, sir? Whether zooplankton or phytoplankton? Answer me. Kindly, sir. Which are producers among these planktons? Whether it is zooplankton or phytoplankton? Phytoplankton, right, sir? Phyto, the word comes means they are plant. They only have the capacity to do photosynthesis. Thank you, Kalishwaran. Thank you, Uday. Phytoplankton. Okay. They are small micros. Can I tell? These are planktons, these are algae, they are microscopic in size, but they have the capacity to produce what, sir? To do photosynthesis, and they are the producers. Can I tell they are miniature plants? Do you accept that, sir? Yeah, algae is a miniature plant. So even a bigger tree, a massive tree that is having the principle of, they are having the capacity of doing photosynthesis, the same property, it is present in an algae, right? Then can I tell algae are nothing but miniature plant? Or even I can tell, substantiate some other statement, the plants are nothing but the massive form of algae, because both are doing photosynthesis. So when there was evolution, obviously the earth started producing food through algae only. After evolution, through evolution, it get modified as small annual plants, shrubs, softwood trees, and bigger trees. So this will be the source for production or modification of something into a tree. Do you accept it, sir? Are you getting my point, what I'm discussing? Someone said. Yes, it's a beauty, sir. It's very beautiful thing that algae, they are the producers. So here in a terrestrial ecosystem, we people are supplied by any green leaves. We are dependent on trees. We are dependent on plants. But the entire marine ecosystem, or else aquatic ecosystem, even the whales, the size of the whale is assured because of the primary producers, that is the phytoplankton. The only producers in the aquatic ecosystems are phytoplankton. Okay, they produce the food. But these zooplankton, they are animal-like algae, a miniature animal. They start eating this, what's that? Phytoplankton. Right, sir? So zooplankton and phytoplanktons are produced. They are the producers in the aquatic ecosystem. They are present suspended in this aquatic ecosystem. I can tell a limitation up to which the algae will grow. Okay, the algae will not grow in this benthic region or else in the abyssal region in a marine ecosystem. It will be confined to a particular zone. That is the inference. If I am finding a place up to which the algae is growing, right, sir? So say this is the limit up to which algae is growing. Okay, then I can infer that this is the layer up to which sunlight is penetrating. Can you make a sense, sir? This is the inference that this is where the last point of algal growth in suspended manner inside the aquatic ecosystem. Beyond this, there is no algal growth. There is no algal growth. Up to this place only, there is algal growth. I can infer something that up to this limit only sunlight is penetrating. Why, sir? Why, sir? How do I can derive this inference, sir? Because sunlight is very, very pre-requirement for photosynthesis to happen. They are the producers. Understand, sir? So algae will grow up to a zone that is called as photic zone. This is the inference. So algae are confined in aquatic ecosystem. Let it be any kind of ecosystem, marine or terrestrial aquatic ecosystem. They are confined only up to a zone that is called as photic zone. Photic zone are nothing but the limit up to which sunlight penetrates into the aquatic ecosystem. So can I tell this photic zone as zone of protection? So production activity is taking place. The food is being produced here. In land, anywhere food is being produced. But in aquatic ecosystem, there is a demarcation, and sunlight is the boundary. The entry point, the entry limit of sunlight is the boundary for demarcating something as which is the boundary for zone of protection. Photic zone will be the zone of protection. Sir, these are important, sir, both for films as well as mains. Make a note on zone of protection in an aquatic ecosystem. Then you have to draw this. Sunlight penetrates up to this area. So algae will be present in here. Here photosynthesis is possible, and they are the producers. They are the food supplier for the entire aquatic ecosystem. Understood, sir? Any doubts you have? Shall we proceed? Sir, someone, sir, is it is clear? No doubts. Yes, thank you, thank you. Clear, clear. So this is zone of protection up to which algae is present. Next is nekton. So we have to know some details about algae even, sir. So what are algae? One algae I discussed earlier that the algae are nothing but they have higher potential to transform the unavailable nitrogen even to available nitrogen. Then imagine how much energy, the immense energy they possess. At the time of lightning only this is happening, conversion is happening, but simply a microorganism is converting this unavailable nitrogen and fixing the nitrogen as leg hemoglobin in the form of root nodules in a leguminous crop, in a pulse crop. Then imagine the power of microorganisms, right, sir? So these algae, they can be classified based on its pigment, right, sir? So I'll take a first page. How to classify algae? So algae, they do have some, they do have some locomotion. But the locomotion, the movement is very limited. They can't roam freely. Okay, say a water body is there. From here, this algae can't move here. There will be some limited locomotion. Okay, sir, they can move. This movement of this algae is aided by something called as flagella. Right, sir? Flagella. If a algae has a single flagella, it is called as monotrichous. What is trichology, sir? What is trichology? This is called as monotrichous algae or monotrichous flagella. Monotrichous flagella means when only a single flagella is attached with the body of the algae. Only single flagella is present. Right, sir? First, I will finish it. Monotrichous. Bitrichous means two flagella are associated in the body of the algae. Two flagella are present. Amphitrichous. Amphitrichous, that is throughout the body of the algae. Okay, many flagella is present. That is called as amphitrichous flagella. And some condition that is called as lopotrichous. Lopotrichous. Here also many number of flagella is present, but with a difference in the body of the algae. Many number of flagella are associated. They are confined in one particular area. It is called as tuft of flagella, as like a grass grows. Right, sir? You can pluck the grass. Okay, the grass has various number of tillers like this, right, sir? A single grass will have various number of tillers like this. They will be attached through the root to the soil. In the same manner, many flagellas are present here also in comparison with amphitrichous, but they are confined to one particular area. They are not distributed throughout the body. This condition is called as lopotrichous. So the key word here is tuft of flagella. Tuft means Tamil kotta. Kotta ஒரு இடத்துல இருக்குது. Tuft of flagella. This condition is called as lopotrichous flagella. Right, sir? This is in association with the number of flagella. Again, how do I can classify algae, sir? Based on the type of pigment present, there are various colorful algae, right, sir? So, cyanophyceae. Cyan means blue color. So, I told phycology means study of algae. So, cyanophyceae is nothing but blue algae. Cyanophyceae or else blue-green algae. Okay, sir. Red algae is called as erythrophyceae, erythrocene. Erythro means red color. So erythrophyceae is nothing but red algae. Right, sir? The color of the algae will be red. It is generally called as erythrophyceae. And one more color is there, brown color. Right, sir? Normally, we won't know this name. Erythro, we might have heard somewhere. Cyano with cyan, it means nothing but blue color. So no confusions in erythrophyceae and cyanophyceae. Whereas brown algae, it is called as phaeophyceae. Okay, sir. This is very, very important. Brown algae is called as phaeophyceae. In most of the competitive exams, they used to ask this. Okay. And we know xantho means yellow color. Okay, xanthophyceae means yellow algae. Likewise, the color of the algae changes according to the pigment present in that particular algae. These are some of the extra details about algae. What do you have? You have to know at the basic level. So xantho is yellow algae, brown algae is phaeophyceae, erythro is red algae, and cyanophyceae is blue algae. Okay, sir. I will go back, sir. Okay, so see here, this is photic zone, up to which algae are present. Beyond this limit, sunlight will not penetrate. It will be dark in color. We can't see. It is visible. It's not visible here. It is aphotic zone. So aphotic zone is present. Absence of sunlight is present here. So obviously, food production will not take place. So it becomes a zone of consumption. Whatever food is produced here, It will be consumed. Only consuming activity and decomposition activity will be taking place. Aphotic zone. It is zone of consumption or zone of decomposition. The lowermost area will be zone of decomposition. Because whatever organism which is present here, see the new stone, that is the free swimmers. After its lifespan, it will sink and die and reach the benthic zone. So some microorganism present here in the soil, they will decompose it. So aphotic zone, which activity is highly pronounced? Decomposition activity will be highly pronounced. Photic zone, production activity will be highly pronounced here. Here it is consumption. So nekton, the third level of organism, right sir? Come to here, fourth level of organism, that is called as nekton. They are the hero of this aquatic ecosystem. They are the free swimmers. Algae, they are the producers, that is phytoplankton, but with limited locomotion aided by flagella. Whereas nekton, they are free swimmers. They can roam throughout the entire aquatic ecosystem. Nekton, swimmers, free swimmers. Out of its own will, the fish, they will start moving as a schools. As a group, they used to move. The school of, it is called a school of fish. It is called a shoal or a school of fish. A shoal of fish. A group of fish will migrate, will move. It is called a school or a shoal of fish. Normal school spelling and SHOAL. A group of fish movement. According to its will, they can freely roam. Whereas benthos, it is nothing but decomposition will be taking place. So these are the classification of aquatic organism. Newstone, the topmost layer, air-water interface, and next one is periphyton. They are attached to the submerged organism in the periphery in a clinging manner. They hold fast. They will tightly hold the plant because there will be water action continuously. So the plant will be moving then and there. So they will be clinging. They are called as periphyton. Plankton, they are the producers. Free swimmers, they are called as nekton. And benthons are the decomposers. And we have seen this thing, photic zone and aphotic zone. Okay, sir. This pelagic zone, this is for marine ecosystem. Whereas limantic zone, that is for pond or lake. If it is a marine ecosystem, it will be coming as, instead of limantic, you have to tell it as pelagic, because the ocean zone is wider. The marine ecosystem will be very much farther. So the topmost area is called as pelagic, mesopelagic, epipelagic. Okay, sir. Like this way, there are various categories in the pelagic zone. Meso means middle layer of the pelagic zone, the open area. Benthopelagic, that is the lowermost area. Epipelagic, they are the topmost open marine eco layer. Epipelagic. Whereas littoral zone, as like this, in a marine ecosystem, we will have, after littoral zone, we will have something called as neritic zone. Just know this, that is sufficient. Okay, sir. In a marine ecosystem, just after littoral zone, there will be neritic zone, then followed by pelagic zone. Okay, what happens, sir? Suddenly, as like photic zone, in a marine ecosystem also, the algae will be present suspended in the topmost layer up to which sunlight is penetrating. Okay, if sunlight penetration is up to this point, the production zone will be confined to this area. Algae will be confined to this area only. Okay, when you are going deeper into the water, the salinity will increase. If I'm adding salt in a tumbler of water, in a glass of water, the salt entirely will dissolve. Okay, after some time, if I drink the topmost water, it will be somewhat less bitter. Whereas it will be less salty compared to the innermost layer of the glass. So because salt particles will get deposited in the bottommost layer after dissolving in water, right, sir? The same principle applies here. In marine ecosystem also, so we know that the salt concentration is above 35 ppt. The dissolved salt, it is evenly distributed. Even though it is evenly distributed, the heavier salts after dissolution, it will get deposited here in the top, in the lowermost layer. That's why salinity is increasing with increase in depth. When the depth is increasing, salinity will also increase. Whereas when the depth is increasing, the temperature will decrease. If I'm going deeper inside, the temperature will decrease. Suddenly there will be change. There will be change suddenly in salt concentration if I'm going into a marine ecosystem. Up to this area, there won't be that much variation in salinity. More or less, there will be even salinity present in this area. Suddenly, there will be an increase in salinity. This sudden place is called as halocline. This limit is called as what, sir? Halocline, the point at which there is a sudden change or sudden increase in salinity in a marine ecosystem is called as halocline. In the same manner, after some point, there will be sudden decrease in temperature. If you are swimming even in 9 o'clock or 10 o'clock p.m. in the open sea or ocean, you can feel the warmthness, the topmost layer. More or less, it will be warmer, the topmost layer of the ocean. But if you are going deeper, even in the morning time in the ocean, it will be more chillness. There will be a sudden change in salinity as well as temperature. The temperature change is called as thermocline. This limit is called as thermocline. Just know this, sir. Thermocline. Based on this statement, you are getting some questions. Okay, sir. Thermocline is the point at which there is a sudden change in temperature. Halocline is the point at which there is a sudden change in salinity. Right, sir? Do you have any doubts in aquatic ecosystem zonation, sir? Is it clear? Shall we proceed with next thing? Yes. Okay, sir. Thank you. So now we'll see something called as eutrophication, a phenomenon called as eutrophication. Okay. This is very, very important phenomenon. It is a bigger menace. It is a man-induced, it is a human-induced activity. But naturally, even this will take place. So first we have to know what is the etymology of this word. You. What is you, sir? What is the meaning of you? You means something which is true. If you want to classify organisms at the lower level, you can classify cells as eukaryotes and prokaryotic cells. Okay, sir. Prokaryotes means first form, which are the pioneer. Prokaryote cells are the organisms which are first evolved organisms. That is called as prokaryotes. So some features will be missing in the prokaryotes, right, sir? Since they are the first evolved one, something will be missing. Whereas eukaryotic organism, they are true organisms, they are well-developed organism, which is complete, which gets the entire thing. That is called as you. That's why a eukaryotic cell is called as a well-developed cell. A well-defined cell is called as eukaryotic cell. In the same manner here, you means true, a complete, fullest level trophication. Trophic means energy. Right, sir? Trophic means energy. When the energy is reached to the fullest level, then it is called as eutrophication. Okay, sir. There is no need of bugging up some definition or anything. When the energy tropical zone, in Earth's surface, equator and adjacent to equator is called as tropical zone, right, sir? Tropical and subtropical zone. Why it is called as tropical zone? The meaning of tropic is nothing but energy. So sun rays falls equator in a vertical fashion, right, sir? That's why it heats this area completely. The energy is fullest in this area. That's why tropical biome, tropical rainforest have higher level of biodiversity compared to any other biomes, since it derives more of energy from sunlight. I can tell energy is fullest in tropical biome. Right, sir? So same manner, this process happens eutrophication, that is, energy is reaching fullest. When it happens, sir, say aquatic ecosystem is in isolation. Adjacent to this, I may have some forest. Adjacent to this area, I may have some agricultural land. Right, sir? So this is an forest ecosystem. This is an artificial ecosystem. That is a human-made ecosystem. That is agricultural land. I may do anything here. Right, sir? So this ecosystem, forest ecosystem, it will be having its own level of energy. That's what we calculated by pyramid of energy or pyramid of biomass or pyramid of numbers, right, sir? If we evaluated this, they will maintain a particular level of energy in this ecosystem. So whenever there is a sudden rainfall, when there is heavy rainfall, so out of decomposition, we will have some organic matter present in the topmost layer of the soil of this forest, right, sir? That organic matter is called as humus. That is partially decomposed organic matter. Humic acid will be involved in this decomposition, and the product what I get at last is called as humus. Partially decomposed organic matter. The organic matter will not completely decompose. Then what is this? The definition tells that humus is nothing but partially decomposed organic matter. But how this humus is reached? The soil, that's what I told, clarity is needed about what is the soil. 100% of soil, 50% is solid mass, 45% is pore space, and 5% is organic matter. This humus is nothing but the organic matter. This makes the soil a perfect soil, a complete soil. Without humus, it will not be called as a complete soil. So say, if I take this example of forest, the leaf materials, after abscission or senescence, the entire tree or leaf will fall in the ground. Right, sir? It will get decomposed by microbial action. Right, sir? So this falling material is called as litter material. Let it may be leaf or anything. It is called as litter material. The waste out of a plant. Litter materials. They will reach the earth. They will get decomposed. And the product what I get is called as humus. Partially decomposed organic matter. So whenever there is a sudden downpour, that is rainfall, heavy rainfall, these humus particle, which is nutrient rich, these are nothing but minerals, right, sir? They will be washed off and they will be added in the aquatic ecosystem. Say a lake. This thing may happen even naturally, right, sir? This is called as natural eutrophication. But when this is reaching the aquatic ecosystem, now tell me whether the production rate will be increasing or decreasing. So some nutrients is being added into this aquatic ecosystem, increasing, right? So surely the algae will be growing luxuriantly. Previously, say I have only 20 kg of, simply for an example, I'm telling, sir, there was only 200 kg of algae production in this aquatic ecosystem before this eutrophication is happening. After this eutrophication, this is naturally happening even. So it is washing off all of the minerals and nutrients and it is adding. Now the entire aquatic ecosystem will get more of nutrients and the algae will start producing multifold. They will reproduce more. They will divide more. So instead of 200 kgs, they will produce 2000 kgs even. Algae, right, sir? Or else 1000 kgs. Say for an example, I'm telling. This is called as natural eutrophication. But out of natural eutrophication, when this is produced, when this production rate is increased, the consumption, that is the nekton present here, the free swimmers present here, they also consume in a faster manner. They will keep pace with the production phase. The consumption phase and the production phase will make a stability, will reach as a equilibrium. Nothing will surpass each other. Then I can't tell that this ecosystem will collapse. So here, after modernization in agriculture, we are practicing modern form of agriculture. We have filled out the forest here. Here, instead of forest, we have now agricultural land. Right, sir? Clear filling of forest. That is called as filling, removal of the forest tree species. We are converting this land as agricultural land. And I need more of outcome, economic outcome from this. So I'm giving all of the inputs in the form of inorganic fertilizer. Okay, sir. I need excessive outgrowth. I need exorbitant, I need phenomenal yield increase. Okay, sir, because today's agriculture is marketing based agriculture activity, right, sir? I'm producing my product to sell in the market. So my aim will be in increasing the yield. To increase the yield, I will apply all of the inorganic fertilizer here. Inorganic fertilizer means nothing but chemical form of fertilizers. If it is natural form, it is called as manure, right, sir? From cow dung even we can produce some fertilizer, but it is a natural fertilizer that is called as manure from cow dung or litter material. See these fellows, this also added some litters previously when there was forest, but these litters are organic derivatives. So some cattle will be present in the forest, animals will be present in the forest. Okay, so they will add manures. They will be partially decomposed. Whereas agricultural land, it is inorganic fertilizer. Now when there is sudden downpour, the excessive fertilizer will be washed off into the aquatic ecosystem. Okay, now there will be multifold increase in the production rate. So say here an example, instead of 200, in natural eutrophication, there was 500 kg of production. But suddenly there will be 2000 kg increase of the production. Okay, sir. So this type of human induced action is called as cultural eutrophication. Man-made activity is called as cultural eutrophication. So say we are having some industries in this area, a leather industry. They left out effluents. They will be reaching the aquatic ecosystem. Okay, sir. From the leather, the minerals will be washed off. Okay, I'm having a sago factory here. I'm having an agriculture factory here. I'm having a chemical factory, say some fluorescent lamp production. From this, mercury will be reaching. Likewise, from various industrial source, all of the minerals, the effluents from effluents form, they will be added to the aquatic ecosystem. The minerals is being dumped, the nutrients is being dumped here. So production rate will be multifold higher. So what to their level best, the necton will try consuming it. But even after consuming, so at the initial stage, the algae will form an algal bloom, right, sir? The entire layer will be covered with algae. So see in this right side diagram, sir, this is algal bloom. I can't even see the water. The entire area is covered by algae. Okay, so as like a mat, this is called as algal mat. They combine together to form a mat, right? So the entire area, the topmost surface of the water is covered by algal mat. This condition is called as algal bloom. They are not proliferating. They are not multiplying. They are doing uncontrolled cell division, uncontrolled multiplication, utilizing these excessive nutrients. Okay, sir. Utilizing this external source of excessive nutrients. This is the keyword. So eutrophication, when I'm speaking something as cultural eutrophication, the first action is addition of or entry of external source, because it is not present directly inside the aquatic ecosystem. It is external excessive nutrients. The nutrients is coming from external fashion in an excessive manner. External excessive nutrients is being added. This is the first action. The next action, algal bloom will happen, right, sir? They will form an algal mat. So the second action will be algal bloom. Why this algal mat is formed? So say previously, if there is no addition of nutrients, if it is relying on the nutrients present in the aquatic ecosystem, when production is taking place, the necton will be consuming. The necton will be consuming. So the water will be clear. So some algae will be produced, the algae will be eaten by this fish species or whatever aquatic organism present there. Now the water will be clear. Now I can utilize this water even for drinking activity since the water is clear. when the eutrophication is not proceeding. When natural eutrophication is happening also, this menace will not be taking place. When cultural eutrophication is happening, the algae, the production rate will surpass. The production rate outnumbers. The production rate is uncontrolled. So even the bigger fish species, they'll keep trying to consume it. At one point of time, they can't consume more. Even after consumption, they will start blooming, algae will bloom, and they will form an algal mat. That is the action taking place here. Algal mat is formed, second action. So once the algal mat is formed, what happens, sir? The very entry of the sunlight is restricted. Now, see in this diagram, sir, second diagram, sir. Now the entry of the sunlight is not possible here. So sunlight can't penetrate here, it is being reflected, or else it will be trapped here. It will not come inside. So there is no any mixage of atmospheric oxygen. Atmospheric oxygen can't get dissolved here. So whatever organism, say necton is present here, they have to thrive upon. They have to live with the limited dissolved oxygen present in the water, in the closed water now. It becomes a closed body. It is no more a open water body. Okay, sir. It becomes a closed water body. So whatever organism which is present here, they have to respire with the limited oxygen present in the mat formation condition. The entry of the oxygen is not possible here. So this condition is called as biological oxygen demand. So whatever organism present in the aquatic ecosystem, all will be competing for the limited oxygen. So the demand for oxygen is increasing. So when eutrophication is taking place, BOD will increase, biological oxygen demand. So suddenly, since it is a closed ecosystem now, after cultural eutrophication, there will be sudden depletion of oxygen. At one point of time, suddenly what happens, sir? The entire oxygen present in the ecosystem will be completely utilized. There won't be no more oxygen for the respiration of other organisms. So all of the organisms present inside, they will die and they start floating. You can find fish floating over the algae, over the water surface. Sudden death of aquatic organism. They will die and float over this thing. So why this is happening, sir? I can even tell this. The consumption phase can't keep pace with the production phase. Whether the statement is right, sir? How to recover the pond from algae, sir? Sir, I will tell, sir. I will deal it, sir. Okay. A very good question, Kalishwaran. Thank you. Thank you. Thank you for reminding me. So in this manner, we have lost many number of lakes and ponds these days, sir. Wherever there is industry, wherever agriculture activities in inorganic manner is highly pronounced, we are losing ponds. The pond as a viable ecosystem is being converted as an unproductive ecosystem. I will come to the point, sir. So I told why this is happening, why this menace is happening is the consumption phase can't make phase with the production phase, or else the production phase exceeds the consumption phase. These are the two conditions whereby BOD increases. The production phase is higher. To make it simple, the production phase is higher. Production phase is higher than what, sir? Is higher than consumption phase. Consuming phase. That is consumption phase. This is the condition. This is the condition where there will be sudden death of organism. So see, in atmosphere, oxygen is present in the percentage is 21%, but it has to get dissolved in the water in a normal condition. Say, in normal condition, the oxygen present in the atmosphere, it has to get dissolved in the water. So the amount of dissolved oxygen will be more than 100 times lesser than the atmospheric oxygen. Generally, even if there is no any algal growth completely, normal dissolubility is very less in water. Okay, sir. Again, if the water is more warmer, if the water temperature of the water is increased, the dissolubility of the oxygen is reduced. These inference you have to derive, right, sir? So normally the oxygen present in the aquatic ecosystem in the dissolved form is 100 times lesser than the atmospheric oxygen. Then imagine, sir. That's why the fish species keep on opening its mouth. They have to consume more of water to take more of oxygen. All of the aquatic organisms, they have to consume more of water to take more of, to avail more of oxygen. Right, sir? Now, out of algal bloom, the entry itself is cut off. Then already there is limited oxygen. There will be sudden depletion of oxygen at one point of time, and there will be floating of aquatic species. Right, sir? These are the inferences. Biological oxygen demand is increasing. Now, the entire ecosystem, closed ecosystem, they are closed. So what happens? The decomposition is not proper. Right, sir? The decomposition is not proper. If I find a rat dead in a concrete surface, okay, I will get the smell. Right, sir? It may create some, it may produce some poison. The air will be polluted. But if the rat, if it is dead over the soil, in the forest soil, I can't feel that much smell. Because the soil microbes, there is a chance that it may get decomposed. In the same manner, here, since it is closed, decomposition is now decay. Right, sir? It is partial decomposition. Decomposition will not be taking place in a wiser manner. So it starts producing some toxins. This is called as neurotoxins. The entire water, if I drink the water now, I will die because they will produce some toxins called as neurotoxin, which is going to affect my nerves. Neurotoxin. The entire aquatic ecosystem will get converted as poisonous one. These are the effects of what's that? Eutrophication. Have it in mind. Cultural eutrophication, that is the man-made eutrophication, is very worst form than natural eutrophication. In natural eutrophication, the ecosystem will retrieve to the original condition. In cultural eutrophication, it is multifold. The effect is multifold. It is uncontrollable. Okay, sir. So we stop here. Kalishwaran, I will come to your doubt after the break, sir. Okay, shall we take some 10 minutes break? Okay, sir. Okay. Sir, kindly ask me some doubts, sir, if you have then and there. Okay. Yes, Nikki. Difference between decompose and decay. Right, sir. So I'll come to that point, sir. Shall we start? Shall we proceed, sir? Are you there? I think we are going in a very slow phase. Shall we start, guys? Yes, sir. Yes, sir. Yes, Dinagar. Okay. So where I stopped is the effect of eutrophication. So neurotoxins is produced. So the entire ecosystem is poisonous now. Now there is no more organism. All organisms are dead. Okay, decomposition is not taking place with the fullest level. It is called as decay. Okay, when the decomposition is completed, okay, decomposition is the entire decay process. When the decay process is completed, it becomes decomposition. After decomposition, it will be converted as a mineral. Okay, so decay is the initial process of decomposition, Dinagram. Okay, now what happens? Still, the action of sunlight will be there even after this BOD or algal bloom. Now the level of water will get reduced out of evaporation. The water table was up to this limit, water level was up to this limit. Over a period of time, the water level will be reducing in a consistent fashion due to the continuous action of sunlight. Evaporation will be taking place from this water body. After some time, the water body level will be reducing and they will reaching the soil level. There won't be no more water. Understand, sir? வடிவேல் ஜோக் சொன்ன மாதிரி கிணத்த காணான்ற மாதிரி ஆயிரும், குளமே காணாம போயிடும். யூட்ரோஃபிகேஷன் நடக்கிறதுனால கடைசியா குளமே இல்லாம போயிடும். There won't be a water body. The entire water body will become shallow. It will become dry. So once upon a time, before eutrophication, that particular ecosystem was very, very stable and viable, and they were supporting various organisms. It has various uses and utility for humankind, for nature. But when man-induced action is taking place, the entire lake disappears. The entire pond disappears. So the last stage of eutrophication result is conversion of a productive ecosystem into an unproductive ecosystem. Conversion of an aquatic ecosystem into a terrestrial ecosystem. This is the last result, sir. End result, sir. We can simply tell in a statement. More statement la sollidala. Conversion of a aquatic ecosystem in a terrestrial ecosystem. ஆனா உண்மையா அதோட ரிசல்ட் என்ன? இதுக்கு முன்னாடி ஒரு லேக் இருந்துச்சு, இப்போ லேக்கே இல்ல, அன்ப்ரொடக்டிவா மாறிடுச்சு. Okay, in this manner we have lost various lakes after modernization, after more of industrialization, after more of inorganic agriculture. Okay, if someone asked in which way we can reduce this, sir, how to reduce this algal growth, sir? So this eutrophication may be either point source or else non-point source. Point source eutrophication or else non-point source. What is point source? If I can find out from where the minerals or nutrients is reaching the aquatic ecosystem, if I can pinpoint, if I can tell exactly from this activity only, from this action only, the nutrients is entering into an aquatic ecosystem, then it is called as point source. So previously this ecosystem is viable. After construction of an industry, this thing is happening. The wastages from the industry, that is the effluent from the industry, is being released into an aquatic ecosystem. Then there is algal bloom. Previously there was no algal bloom. This is called as point source. If I can track from where the effluence is being entering into the ecosystem, then it is point source. Whereas non-point source, I can't find out, I can't track. Even after some complete study, I can't track from where the wastages or nutrients is coming, then it is called as non-point source. So agriculture, it is an inorganic fertilizer is getting added. So how to reduce this, sir? That is the bigger menace now. We have pond in all of our villages. So adjacent to this, we have agriculture field. The inorganic fertilizers, when there is heavy rainfall, it is coming into the aquatic ecosystem. How to control? Then I have to go for nitrogen analysis before application into a soil. If I'm going to apply some nitrogenous fertilizer to a crop, Before application, I have to go for N testing, that is soil testing has to be made. If I'm doing soil testing, then the agriculture department fellows will tell that this is the amount of nutrients present in your soil and this is the level of fertilizer you have to apply. What is the exact requirement of the fertilizer of that particular crop will be specifically told, will be specifically given by the agriculture officials. Then, so that there won't be any wash off. There is no chance that excessive nutrients will be washed off because I'm applying only limited, or else what is the exact amount of fertilizer requirement of the crop is being added after soil test. This is one of the method. Or else shifting to organic agriculture, that is one of the method. Okay, industrial waste treatment. Before releasing the effluent directly into the aquatic ecosystem, I have to go for wastage treatment by bioremediation, or else by filtration methods, by reducing the level of pollutant content. Right, sir? These are some of the methods how we can control this eutrophication. So have it in mind, the last stage of eutrophication is conversion of a productive aquatic ecosystem into an unproductive terrestrial ecosystem. Understand, sir? Next one, sir, biomagnification. So before biomagnification, we have to know what is bioaccumulation. These are the two processes that is happening. So accumulation means getting dumped of anything. So say I'm having some, we are having some in Kodaikanal, adjacent to that lake, we have some fluorescent lamp industry. One industry is producing fluorescent lamp. For fluorescent lamp production, we use mercury as an ingredient. Okay, this mercury, if it is untreated and released directly into the lake ecosystem, that will get converted into methyl mercury. Methyl mercury or methyl mercury. Now, this will be utilized by the producers. So the algae will utilize this. It will get entry, this inorganic substances will enter into the algal body. When a fish is consuming this, the fish body will be having what, sir? Methyl mercury. Again, the fish is being consumed by me. So this entry point is called as bioaccumulation into any organism. So the algae, previously it was not having methyl mercury or anything. Now this methyl mercury got entered into this algae. This entry point is called as bioaccumulation. Okay, sir. So all bioaccumulation, there is no need that it should be fatal. It should result in death of organism. It depends on the chemical which is going to enter into the body. So then we have to know about the basic essence of what is a chemical is. So we are eating in modern day, I can't tell that I'm eating a complete organic product. We are applying pesticide. We are using fertilizers, inorganic fertilizers, synthetic fertilizers. Synthetic means human produced, chemically derived, which is produced in industries, which is manufactured. These human made chemicals are called as POPs. What's that? POPs, persistent organic pollutant. These are man-made chemicals. This becomes a menace. The entire organism is made up of chemical. That is not a matter. The chemical is being recycled, organic chemicals, right? But POPs, that is a persistent organic pollutants. These are synthetic chemicals. These are man-made chemicals. When this enter into our body, it will get bioaccumulated. Okay, sir. Whatever, so that's what I'm insisting. So we are consuming all kind of foodstuffs, but the foodstuff what we are consuming now, they are having some inorganic chemicals. But when I consume it out of my metabolism, okay, metabolism will be happening in my body. That is after digestion, the unwanted things will be released from our body. If the chemical is soluble in water, the chemical which is entering into my body, it will get accumulated. When the chemical nature is water soluble, that will be released as a urine. The waste chemicals present in our body, which enter into our body, will be released through urine, since it is a water soluble chemical. but some chemicals are not water soluble. Then they will get fixed in our body. Then our body will get bioaccumulated. Understand, sir? So, see, based on the type of wastages removal, we can tell ammonotelic. This is the mechanism of waste removal from our body. Ammonotelic. Sir, when there are organic food being certified in Bharat Tag, it's an exception, right, sir? Yes, sir, right, sir. They won't get accumulated. Ammonotelic, ureotelic, ureotelic, uretelic, uretelic. These are the kind of waste removal from any body from an organism. So, if some organism is removing the wastages in ammonia form, then it is called as ammonotelic organisms. So, if I want to remove something, I need more of water. So, this is possible only for aquatic organism. So, fish, they are always present in water. There is ample water supply, so they will release all of the aquatic organism. They will release wastages in the form of ammonia, because to remove ammonia we need more of water. So ammonotelic kind of excretion is pronounced in aquatic organisms. Okay, sir. Ureotelic. If you see our body, we will release wastages in the form of urea. Right, sir? Our urine contains urea. Ureotelic, whereas uricotelic, URICO, right, sir? The last one is uricotelic. What is uricotelic? So here, instead of urea or instead of ammonia, the wastages is removed in the form of uric acid. So these are some basic things we have to know, sir. So when the wastages are removed in the form of uric acid, so the wastage is coming from the body as an acid, uric acid. So they will be in pellet form. They will be highly in a condensed form. Okay, they will be in pellets. If you see the droppings of the lizards, okay, if you notice the droppings of the lizard, you can find some white coloration and black coloration. In the same fecal matter, you can find some white coloration and black coloration. This white coloration is nothing but the urine of that lizard. They will release, since the lizard will not take too much of water, they won't consume too much of water, they won't drink too much of water. From the whatever insects they eat, they will derive water. So the water availability is very less, so they won't lose water from their body. They have to conserve water from in their body. So instead of releasing as urea or else ammonia, they will release in pellet form. This is uric acid. Understand, sir? So generally, most of the organisms which are living in desert condition, where water is limited, water availability is very limited, they will release in the form of uric acid. They are uricotelic organisms. Desert living organisms are uricotelic organisms. Are you clear, sir? Now come to this, sir. So simply, some pollutant is getting entered into an ecosystem and it is getting added in one particular, maybe a producer. This entry point is called as bioaccumulation, right, sir? When the fish is consuming this, okay, so this phytoplankton will be consumed by zooplankton. A zooplankton will consume, say, n number of phytoplankton. Say a single zooplankton is consuming some 20 phytoplankton. In each and every individual phytoplankton, there is mercury, right, sir? So imagine the concentration of the chemical now which is entering into the zooplankton. 20. So a single fish will consume around 200 zooplankton. So each and every zooplankton body is now filled with mercury. Right, sir? Now in the fish species, small fish species, the concentration of the chemical is increasing because it is consuming more volume of the zooplankton. This small fish will be consumed by very large fishes. A very large fish will consume more number of small fishes. By the way, the concentration of the chemical in the bigger fish is still more increasing. This level of increase in the concentration of chemical when it is moving from one tropic level to another tropic level is called as biomagnification. The effect of the chemical is getting increased from one tropic level to the another tropic level. So I can tell bioaccumulation is the entry point, whereas biomagnification is increase in the concentration of the chemical when it is moving from one tropic level to another tropic level. See here, sir, water. Chemical is entered into water. After entering in water, it will be utilized by producer, that is the algae. Here the concentration in algae is 10,000. Whereas when it is going to zooplankton, it is 10,000. By this way, it is getting increased to a multifold level. The concentration of the chemical from the lower tropic level to higher tropic level, it is increasing multifold. When it is reaching the topmost predator, topmost consumer, the concentration of the chemical is very, very higher, so that it will become poisonous and there will be sudden death of the topmost consumer. In this manner only we lost vulture population. Okay, biomagnification is nothing but the increase in the concentration of the chemical while it is moving from one tropic level to another tropic level, and the topmost carnivore will become fatal, it will die. So here biomagnification occurs if a pollutant such as DDT, that is dichloro, diphenyl, trichloroethane, that was used as an insecticide. Post World War II, we used this DDT as a popular insecticide. Actually, it was used to control malaria initially, right, sir? Now, then they shifted this to agriculture purpose as an insecticide. So mercury that we discussed, methyl mercury, PCBs, polychlorinated biphenyls. If you see some transformers, electronic transformers in urban area or else in village area, there will be some transformers. Okay, they will distribute the electricity evenly to household area. Beneath the transformers, you can find some leakage of oil. These oils are nothing but PCBs, polychlorinated biphenyls. Even now also in many parts of India, they are using it for malaria. Yes, sir, yes, sir, yes, sir. But this DDT, actually it was banned in 1970, 1980s. During 1970 to 1980s, this DDT was completely banned, but we have various other forms of DDT. Okay, sir. So beneath the transformer, where there is a leakage, you can find some oily spills. This oil is nothing but polychlorinated biphenyls. So when there is a rainfall, these PCBs will reach the aquatic ecosystem. In industry, it is used heavily. These PCBs are used. Those industries which are present adjacent to the marine ecosystem. So these PCBs will be persistent for long duration in marine ecosystem, and they will enter the aquatic organism and increase the biomagnification and results in death of the larger organism present in the aquatic ecosystem. Understand, sir? So bioaccumulation, I can't tell that all bioaccumulation will lead to death, whereas biomagnification, the topmost predator, obviously it will die because the chemical concentration is keep on increasing, moving from one tropic level to another tropic level. Okay, sir. Any doubts in this concepts, biomagnification and eutrophication? Do you have any doubts, sir? Shall we proceed? Yes, sir. The persistent organic pollutant, Stockholm Convention is there. Sir, is there any natural cause for biomagnification? Sir, naturally chemicals won't get moved, sir. Because if it is a natural chemical, Nikki, if it is a natural chemical, it will be removed from as a wastages out of the metabolism activity of a concerned organism. The concerned organism, when natural product is entering in our body, it can be released outside. It doesn't harm us. Sir, can you give a brief about the Stockholm Convention? Yes, sir. We'll do it later, sir. Chemical oxygen demand. Okay, sir. The utility, the availability of oxygen for the chemical activity. Yes, sir. We proceed, sir. Next, we will come to a simple topic. It is a kind of aquatic ecosystem, right, sir? It is an example for ecotone, mangroves that we discussed earlier. What is an ecotone? The meeting point of two different ecosystems, right, sir? One more doubt. Yes, sir. Everything we'll discuss in coming sessions, sir. Yes, sir. We'll discuss. Ecotone. This mangrove is an example of ecotone. Okay. Actually, it is a intermediate area between a terrestrial and an aquatic ecosystem, right, sir? So water activity is there. By the same way, there is a terrestrial ecosystem. So nutrient flux will be there from terrestrial area as well as from water area. So what is a mangrove, sir? What is a mangrove? So the definition tells that mangroves are nothing but halophytic organisms. So I told halocline, a word, a term called as halocline. It is the line, it is a point where there will be a sudden increase in salinity. So halo means something which is related with salinity. That is the salt content. So these organisms are halophytic organisms. Littoral halophytic organisms. Halophytes. So saline tolerant. These organisms are, these tree species are salt tolerant species. Littoral tree species. They are confined only to tropical and subtropical zone. Mangroves you can find only in tropical and subtropical zone in a halophytic condition. Okay, sir. Repeatedly we get questions about these mangroves. They act as a first line of defense against tsunami, right, sir? We will see here, sir. So mangroves, if there is a mangrove tree species, can you tell some popular example for mangroves? Sir, the world largest mangroves are present in India. It is present in West Bengal, right? Sundarbans. The name itself is, yes, sir, thank you, Sundarbans. The name itself is Sundarbans. It means Sundar Vanam. Vanam means forest. Sundar. What is Sundar? It is because of the tree species present here. The mangrove tree is called as Sundari trees. At least I know one name for a mangrove tree species. It is called as Sundari trees. That's why this forest is called as Sundarvanam, Sundarbans. So beyond this, we have various number of mangrove tree species. Eritrea. Okay, Eritrea. Abyssinia, Rhizopora. These are some of the examples of mangrove tree species. Rhizopora. Okay, these are examples of mangrove tree species. So what are the utility of this mangrove, sir? You see in this slide. Benefits to human. It provides clean water. We'll discuss. They are safe ground for fish, shellfish, mollusks, etc. They have medicinal values, wood, fuel construction, honey, alcohol, right, sir? Shoreline stabilization. If trees are present in the coastal area, it will stabilize the shoreline, right, sir? Research data, education, recreation, tourism, biodiversity. So Sundarbans, they are the world's first largest mangroves, the world's second largest mangroves we have in Tamil Nadu, that is Pichavaram in Sidambaram, right, sir? Pichavaram, right? So these are the benefits. We'll come to this, sir. So I told these mangroves are nothing but halophytic organism, that is saline tolerant organisms. See, if a tree has to grow, if you find any tree in a terrestrial ecosystem, say a mango tree is present in our area. So the mango tree is alive because the soil, there is mixage of oxygen, there is entry of oxygen into the soil. By the way, respiration is possible. the roots can respire, right? So one thing, the primary thing is, if a tree or a vegetation has to survive, there should be some pore space. Through this pore space in the soil, oxygen has to enter. But see here, sir, is there is any chance that, see this diagram, is there is any chance that water can dissolve in the, water can enter to the air pore space? It is throughout the air waterlogged. It is in a waterlogged condition. It is in stagnant water. Okay, sir. So respiration is very, very difficult here. Atmospheric respiration is not at all possible. To overcome this, they have a kind of modification. They start giving some roots which is against gravity. So normally, if I'm speaking some tree species, all tree species in a general sense, the roots will grow towards gravity, right, sir? That is a pattern of growth of root. They will grow towards gravity. This is called as positive geotrophic. All of the roots will go positive geotrophic or positive gravity. Whereas here, this is possible because air can enter here in our terrestrial ecosystem. Whereas in this kind of aquatic ecosystem, the waterlogged condition is there. To overcome this, they will send some roots. These roots are called as respiratory roots or else aerial roots. These are negative geotrophic. They are growing against the gravity. Understand, sir? They are growing against the gravity. Negative gravity. They are going against the gravity. These are called as aerial roots. I can see the roots in a aerial manner. It is present outside the soil. Aerial roots, right, sir? If you have watched the movie Tuporivalan, right, in the climax stage, the climax fight they have shooted, there you can watch this aerial roots. Yes, sir. So technically, these aerial roots can be called as pneumatophores. They are called as pneumatophores. So what is pneumatos, sir? Something which is having more of air pores is called as pneumato. Okay, so in this root, you can find various air pores through which atmospheric oxygen will get enter and respiration of this tree species is assured. Even tomorrow we can take the class, sir. Yes, sir. Tomorrow we'll take a class in a dark room. You are taking the class, sir. No issues, man. We are discussing that there is power shutdown. I will try to open the door. 1 minute. No issues, sir. No issues. We'll continue. Okay, at least we'll finish these steps. So one thing is, have it in mind, these aerial roots are against gravity. That is negative geotrophic. Respiratory roots, technically they are called as pneumatophores. By this way, mangroves will overcome the respiratory problem. This is one kind of adaptive mechanism of mangroves. And one more thing I told that it is halophytes, saline. The water is always saline. See, sir, if normally we will get some salinity issue, that is kidney stone formation. Okay, the albumin level and creatine level will increase if there is some salt deposition in our body in kidney. Okay, sir, that will get clogged. That will result in kidney failure. So whatever salt which is entering your body, it has to get released through urine. In the same fashion, even salt has to be released from the tree species. But here there is any chance, sir? Here the water PPT level is very higher. The salinity level is higher. So obviously the plant is subjected to derive the nutrients, or they have to consume this water only. They have to utilize this salt water only. Now, when the salt is getting inside, it may get clogged. To overcome this, they have some filtering mechanism. So mangroves are the only tree species which has some filtering mechanism. Okay, sir. They filter salt. And one thing, sir. So in case of mangroves, they are adjacent to the coastal area. They are present in the littoral zone. See, if I'm taking this example, see, consider this as a ocean water. If I have mangrove here in this littoral zone, there will be continuous wave action, right, sir? And beyond wave action, there will be tide action twice a day, right, sir? Out of the gravitational pull of the moon, there will be tide action. The tide action, so the mangroves, the rocks of the mangroves, the trunk of the mangroves will be subjected to the wave action as well as the rise and fall of the ocean water. That is because of tide action. So the anchorage of the mangrove tree is a question mark. So with normal roots, they can't anchor properly. To overcome this, they will start sending some roots vertically, right, sir? If there is a tree, mangrove tree species, since throughout the year they are present in the water, right, sir? So the normal roots present is not sufficient for anchorage. So from the main branch, they will send vertically some roots directly into the soil as like a banyan tree, right, sir? Vertically, they will send some roots for extra anchorage. They will go deeper into the soil and they will increase the surface area of the mangroves. These roots are called as prop roots. So roots which are emerging vertically, which are growing vertically are called as prop roots. This is an extra anchorage roots. But this is not sufficient. Even in banyan tree, it is called as prop roots only. But this is not sufficient to overcome the wave action, to overcome the wind action. Continuously wind will be there. Tidal action will be there. So from the main trunk, some lateral roots will emerge, right, sir? This is the main trunk, sir, of the tree species. From this, lateral roots will emerge. You see in this diagram, from the main trunk, some lateral roots are emerging. They are giving some extra anchorage. You see, sir, they are spreading. These roots are called as stilt roots. So the point here is they are emerging laterally from the main trunk. They are called as stilt roots. So prop roots is for extra anchorage, stilt roots is for extra anchorage, whereas this fellow aerial roots is to overcome respiratory problem. Right, sir? Pneumatophores. So this is a kind of root modification, and they have the mechanism to fill the excessive salt. They will take, our kidney has the capacity to filter salt. So the entire body of the mangrove tree species, they have the mechanism to filter the salt, but the salt is highly present. So if I'm looking into some other leaves, if I look the back side of the leaf, I can even find some salt crystals. By chance, salt will escape into the tree and the salt will be released outside as salt crystals. When evapotranspiration is taking place, through this evapotranspiration, they will remove the salt. If salt is present in the body, it will become fatal for the tree. So these are some of the adaptive mechanism which is taking place in the mangrove, right, sir? So we have finished the root modification. Next, so I told wave action will be there. When there is tsunami is bringing enormous energy. They bring enormous energy. And if you go for Nagapattinam belt or Chidambaram, at the time of tsunami, we found more of dead bodies trapped in the mangrove tree species. So they will hit the wave action out of tsunami. They will hit only the mangroves first, right, sir? They will hit the mangroves first. So when there is hitting the mangroves, they will reduce the energy of the water. They reduce the energy of tsunami. By the way, we humans are protected here. If there is no mangroves here, the wave action, the tsunami energy will be completely dissipated in the human settlement. Okay, it takes away the entire human population in the coastal area. So that's why mangroves are called as first line of defense against tsunami. They act as a first line of defense against tsunami, right, sir? So when this is happening in an extreme condition, out of this tsunami action, this mangroves, the main trunk will be cut off, right, sir? This top canopy that will be washed away by the wave action into the ocean, or else that they will be detached. Only main trunk will be present. The main trunk is present because of what, sir? Can someone tell, sir, why the main trunk is not washed off? It is cut off at a particular point. This is a logical question, sir. If you can answer, you can answer. Why still the main trunk is present? Can someone, sir? The wave action is cutting up to the main trunk. The topmost area is being detached. Why the main trunk is left out? Out of what reason? For balance, sir. Then, sir, some other point, sir. Because of the prop roots, right, sir? I can't tell only because of prop roots. Extra anchorage roots, lateral roots, right, sir? They are providing extra anchorage. Prop roots, even the prop roots will be cut off up to this area. So that's why these extra anchorage roots will assure the presence of the main trunk even after the action of, yes, sir, stilt roots, Rajesh. Okay, extra anchorage is assuring the tree to be present even after the wave action, even after the tsunami action, right? So what will be the fate of mangroves now, sir? Say if I'm having some 20 acres of mangroves, the entire 20-acre tree species is being cut off by the tsunami action. It is left out without the top canopy. Now how I have to replenish? There is one more adaptive mechanism. This is nature gift to these mangroves. When the main trunk is cut off, from the main trunk, new offshoots will emerge after some time period. Okay, new offshoots will emerge and this will start growing as a new tree. That is what I have shown in this diagram, sir. You see here, this is called as coppiecing. This particular principle, when the main trunk is cut off, see, previously there was a bigger canopy here. The main trunk is cut off. After the main trunk is cut off, many offshoots is emerging. New offshoots, new young offshoots are emerging. This will re-emerge as a big tree. This mechanism of emergence of offshoots when the main trunk is cut off is called as coppiecing. So coppiecing is a principle of mechanism of what's the mangroves to overcome the tsunami action or wave action. So kindly bear 1 minute, sir. Okay. So coppiecing is one more adaptive mechanism. And one more thing. So here, so see in our normal terrestrial trees, sir. In our normal terrestrial, I'm again going for mango tree. Okay, the mango tree produces mango. When the mango fruit is ripened, naturally when it is ripened, it will get detached from the twig and it reaches the earth surface, right, sir? The outer pulpy area will be consumed and the seed will re-emerge as an individual tree, as a sapling. Initially, it emerges as a sapling, right? Later on, it gets converted as a bigger tree. This is the normal mode of establishment in terrestrial ecosystem. But what is the fate, sir? Apply this same condition when the matured part, when the ripened part, when the seed reaches this salt water, what will be the fate of this seed, sir? It is subjected to the action of seed, to the salinity in the sea, right? So the emergence of the seed, the germination of the seed, when it is reaching the ocean or high saline water is a question mark. So to overcome this thing, there is one more adaptive mechanism. That mechanism is called as viviparity. That mechanism is called as viviparity. So organisms either do give offsprings, that is young ones, either through viviparity or else oviparity. So oviparity, organism giving young ones, giving birth to young ones are called as viviparity. Egg laying is called as ovi. Have this in mind, O, as like resembling like an egg. Egg laying capacity is called as oviparity. Giving birth to young ones, we give birth to young ones. We are born, we are present in our mother's womb as a young one. We come outside as a, we are delivered. We are parturited. The delivery process is called as parturition. Right, sir? Technically, it is called as parturition. So now tell me whether we belong to oviparity or viviparity. Whether we are oviparous or viviparous. So someone faster, sir. Whether we are oviparous or viviparous. Ovi. Ovi means egg laying, sir. Are we laying eggs, sir? We are viviparous, right, sir? We are born as a young one. We are not hatched from the egg. Okay. So a human or animals are viviparous. This fellow mangrove mechanism that is called as viviparity for a time period, that is for the gestational period at least. We are there in our mother's womb for 9 months. That is the gestation period. That is called as viviparity. When we are matured enough, we are delivered outside. That is viviparous, right? In the same manner, so to avoid when see here the seed, the fruit, when it is matured, inside this there is a seed, right? So the seeds, when the fruit, if it reaches the salt water, okay, it is subjected to the higher salinity and it will scorches the seed and there is no chance of emergence of this seed, germination of the seed. So to overcome this, as like we human beings do, these seeds, these fruits are still attached with the mother, right, sir? See here, sir. Through the twig, they are attached with the mother. From itself, they start germinating as a new young one, right, sir? A new mangrove tree sapling is emerging, still attached to the mother. The word is very important. They are emerging, still attached to the mother. This condition is called as viviparity. As like we humans do, these also, they are raising their young ones. They are having a gestational period. This is the connection between animals and the, what, sir? Mangroves. After some time period, this twig will rise off. They will rise off. They will get dried and they will get detached. Now they are strong enough. When it is reaching this ocean water, they will re-emerge. Now they are enough to re-emerge. This is one of the adaptive mechanism. So viviparity is one of the adaptive mechanism to overcome the salinity. Understand, sir? Any doubts in these adaptive mechanisms of the mangrove tree species? Yeah, we can proceed, sir. No, sir, clear. Thank you. So next one. So here also there will be some honeybee production. Okay, some honey will be produced. This is called as apiculture. The art of rearing of honeybees is called as apiculture. Apiculture. Right, sir? So here there is a term, they are rich in medicinal uses. We can find various medicinal application. We can derive various medicinal components from this tree species. but compared to the terrestrial ecosystem tree. Why, sir? Because I told this is a ecotone. Obviously, there will be some nutrient flux. Out of nutrient flux, heavy materials will be reaching this area. So these heavy materials will find as asylum here. Okay, when it is present in the terrestrial ecosystem, there is no chance that these heavy minerals will get dissociated. It is getting treated. When this heavy materials is reached here, it is a safer area. It is a prolonged area for the further action of these heavy minerals. These heavy minerals will be made as a plant available form, and they will be getting into the mangrove tree species or whatever organism present here. Say some shelled organisms, molluscus, the crabs. The crab here will be having more of medicinal value compared to the crab which is present in the freshwater ecosystem. The fish species present here, the prawn species present here, its body will be containing more of heavy materials. This heavy materials, if I consume directly, I will die. When it is made, when it is entering into some other organism, it is, then if I consume, then it is organic form. Now it will be having more of medicinal value, right, sir? Some doubts came, sir. So cyclones can any storm action, it will be controlled by mangroves, sir. The energy dissipation is the activity made by this mangroves. I can't tell they have a direct role with cyclones. Out of cyclones, okay, out of storms, out of tsunami, if there is any damage, they will reduce the damage, right, sir? They will bear the shock. They are the first line of bearing shock. That's why they are called as first line of defense. Okay, sir, in a coastal ecosystem. Mitigation. Okay, sir. The bigger disaster will be reduced, right, sir? The bigger disaster will be reduced to a limited level, reduced level of disaster. So see, alcohol, right, sir? So this is a typical thing. So see here, Nipah fruticans. Okay, this is one kind of palm. This is one kind of tree, which is the only kind of tree which is present in a mangrove ecosystem. From this, they will tap toddy, alcohol. Alcohol can be tapped from here, from toddy. Nipah fruticans. So why it is named as fruticans? Because a fruit, when it is fermented, a fruit is nothing but what's a sugar. Fruit has a sugar. When this fruit is fermented, it results in production of alcohol. So have this in mind. Nipah fruticans, they are only confined to Indian area and some parts of Asia. Only in selective regions you can find this thing. Aliyati Kadigal. Yes, sir. Very good, sir. Nipah fruticans. It's a through which we are tapping toddy, that is alcohol production in mangroves. So what are the other benefits of mangroves, sir? Okay, so we can, for boat making, we can take wood from, we can consume wood, we can take wood for fuel. Okay, all of these aquatic organisms, they will choose this mangrove place. You see this mangroves area, sir. They are calm zone. They are very calm zone compared to the ocean area where the wave action is higher. Okay, so from this ocean or marine ecosystem, organisms will invade this ecotone. They will find this place and they will take a chance for breeding ground. Since it is a calmer area, breeding is highly successive here. For reproduction, breeding, asylum. Okay, sir. So it acts as a breeding ground. So ecotone, obviously the biodiversity will be higher. And mangroves, they are always stagnant water here. So they will capture more of carbon dioxide. They act as a natural carbon dioxide sink. They act as a natural carbon sink. They will trap more of carbon dioxide even in the trees as well as in this stagnant area. These are the benefits of mangroves, sir. Shoreline stabilization. Biodiversity is higher. So you see the ecosystem service rendered by mangroves. What we discussed earlier, it is given wood, livelihood. Okay, sir. Fish catching is assured here. climate regulation. I told it sequester, it will store more of carbon. It is 3 to 5 times higher than the tropical upland. Okay, sir, more than tropical upland, it will, even though the mangrove area is limited, but a mangrove have higher potential to capture more of carbon dioxide than any other ecosystem. Compared to any other ecosystem, they will capture 3 to 5 times more of carbon dioxide. Carbon sequestration, carbon storage is possible. Different fish species are present here. Okay, sir. Water filtration. Okay, so how do they filter water? They won't convert this water as a purified water. So say industries are present here. The industry is releasing the effluents. The effluents is nothing. They are untreated wastages from industries. They will be having heavy minerals. The heavy minerals will get stored here. It will be converted to less toxic substance by microbial action. Understand, sir? By this way, water is being purified. It is being filtered. Shoreline protection. These are the benefits of what is the success rate of mangrove by artificial plantation because it germinates in seed itself. Yes, sir. Recent days, the various advancement is there for artificial regeneration, sir. The success rate is comparatively higher. This is called as acclimatization, a term repeatedly as acclimatization. Very good, sir. Acclimatization. What is acclimatization, sir? So if you are, for the very first time, if you are going for a hostel in your college, I will ask, what about your accommodation, sir? Are you fine with your accommodation? If you are going to a new area, we used to ask, what about your accommodation? Have you got accommodated? Okay, sir, adaptability, very good to that. It is adaptability. But we have to adapt in a sociological fashion. Understand, sir? If I'm going to a new area, I have to adapt in a sociological manner with the new culture. Whereas acclimatization, from one place to another place, the plant accommodation to a new area is called as acclimatization. It is not social adaptability. It is environmental adaptability. So Dinagaran asked a question about the artificial plantation. It is all about acclimatization successive rate. What is the level of artificial regeneration which has acclimatization successive rate? Right, sir? So plant adaptation is called as acclimatization, whereas human adaptation is called as accommodation. With people and custom, we'll feeling like fish out of water. Right, sir? Right, sir? Right, sir? Understand, Dinagaran? Okay. Nipah fruticans, that's. So we'll get to the next one, corals, sir. So we saw something about corals. I told something about symbiotic relationship. While dealing with symbiotic relationship, I told corals as an example. Right, sir? So what are corals? So they are submerged in the aquatic ecosystem. They are present totally in a marine ecosystem. Okay, so before this, we have to know what is the ocean relief order that I discussed even previously. From the terrestrial ecosystem, okay, into the ocean relief order comes like this, right? Based on the mean sea level, the water may be submerged up to a particular limit. If it is a very raised layer, instead of like this, if the land is very raised, the water level will be shallow. Just for a clarity, I am making this, but say I will take this as a chance. This is the land mass, right? So this land mass is called as continental shelf. Then towards the sea, it is continental slope. Then continental rise, deep sea trenches, and finally the vast plain that is called as abyssal plain, right, sir? This we discussed earlier, sir. So now tell me where the photosynthetic activity will be confined. Can I find algal growth? Algae prefers to grow in this open area, that is the epipelagic zone. Do algae prefer to grow in the epipelagic zone or else in this continental shelf zone? So I'm asking you a question, sir. Do algae prefer to grow luxuriously in epipelagic zone or else in continental shelf zone? Since we had discussion, I am asking this question. Compared to this area, which area will be having continental shelf zone? Chiranjeevi, thank you, right? So this epipelagic, I told that it is the open sea area. So if water is, so the corollary to this is called as limantic zone if it is a pond or lake ecosystem, right? So in case of epipelagic zone, algae should be suspended in the water. Even I can get a demarcation that is up to the photic zone only. Even in a marine ecosystem, you can find algae growing in a suspended manner. So when it is suspended, it is a tougher task for algae to reproduce or to multiply. Okay, sir. Whereas these are safe zone, continental safe zone. They can rest in this area. Even photic zone is assured. Here, the penetration of sunlight is assured. Up to this limit, this algae will grow. So algae prefer to grow in the continental shelf compared to the epipelagic zone since it is a safe zone. Photic zone is assured here. There is no need of suspension. So corals, as I told, it is symbiotic relationship between polyps and algae. The polyps are nothing but a small animals. Shell forming animals are called as polyps. It's a kind of shell forming animals. Not all shell forming animals are called as polyps, right, sir? All shell forming animals are called as crustaceans, right, sir? Whereas here it is a shell forming animal, calcium shell forming animal in combination with algae, they become corals. Generally speaking, it was even corals are confined to tropical and subtropical area. Even if there is a small change in salinity, even if there is a change in pH, there won't be corals. Even if there is a small increase in the temperature range, corals won't be there. So see, sir, the first diagram, these are the polyps. These are the original polyps in isolation. These are the animals, the shell forming, skeleton forming organism. So our bone, what do our bones have, sir? Our bone is white color. What our bones has? What our bone is made up of? Make it faster, sir. Kindly, sir. Someone, sir. Our bones are made up of what? Calcium, right, sir? So, can I tell? Thank you, thank you, thank you. So, here also, it is looking like a bone. These are skeletonous organism. So, they are dominated by calcium minerals. Our bone is made up of calcium and phosphorus. So, here, the entire polyp is made up of calcium. They need calcium to build their shell. Okay, to build their skeleton. The world's richest biogenic source of calcium carbonate is coral polyps. Naturally occurring calcium deposits are present in corals. Okay, sir. Actually speaking, the polyps, that is the animal in isolation, they are white in color. Okay, these polyps are present in the continental shelf zone. They are growing the continental shelf zone. So algae previously, which was suspended, which was growing suspended, they will take chance, they will take this polyps, they will use this polyps as a home. So they now start growing upon this coral polyps, right, sir? Now can you see the color of the polyp in the second diagram, sir? We can't see the color of the polyp. You see, there are various colors of algae. The corals gets the color because of the algae. The polyps are colorless or white, whereas corals are colorful. The rich color of the corals is because of various type of algae. See green algae, chlorophyceae pigment involved. Okay, sir. See yellow algae, xanthophyceae pigment is involved. See reddish pink algae, it is erythrophyceae. See here brown algae, it is paleophyceae. All of the algae which were freely roaming in the ocean, now they prefer to get attached with these polyps. They start growing in a happiest manner here in a symbiotic association. I told when it is symbiosis, both the organisms should have to help each other. So this polyps acts as a resting place This gives shelter for this algae. Right, sir? By the same manner, since it is having more of calcium, the calcium will be utilized by the algae. And whereas the algae is photosynthetic organism, right, sir? It will supply some nutrients to these polyps. By this way, both of these organisms will mutually, compulsorily help each other to emerge something to be named as coral. This is called as symbiosis. That's why mandatory mutualism or compulsory mutualism is called as symbiotic relationship. Corals is an example of symbiotic relationship organisms. So what will be the benefits of this coral, sir? So before that, we will see how this coral growth will be happening. So this is the littoral area, the shallow area where the ocean is coming to the terrestrial area. So if there is heavy rainfall in this area, after heavy rainfall, the rainwater, the river water will bring all of the sediments. When all of the sediments is hitting this coral, say in this diagram, if the all of the river water is hitting this coral, now whether the algae can grow in a calm manner, sir? Can the algae grow in a calm manner? The algae will be agitated. Okay, the force of action brought by the sediments, they will remove the algae. So now the algae starts getting detached from these polyps. Now the polyps will gain the original color. This is one way of natural coral bleaching. When there is more of river deposits, when there is more of sediment deposits reaching the coral area, the algae won't prefer to grow with the polyps and they will get detached. Now the corals will attain that the polyps will attain the original color. This is called as coral bleaching. It is a bleached condition after bleaching powder. This white in color, right? Removal of the stain, that is bleaching, right? So coral bleaching, whatever colors are present, the colors are being detached. That is, algae is detached and the polyps will retain the original color. Okay, so if this is happening, if this condition is prevailing, see, sir, in this diagram. So all of the fish species which are present in the all of the necton species, all other organisms, they will come and take a chance. They will hide inside this place. They won't even move. They won't even roam because always there is assured source of algae. There is a producer. There is food is available for this species. Swimming organisms, aquatic organism, assured source of fish will be assured source of food will be present for the fish species. That's why the entire aquatic organism, they prefer to roam in and around corals. Okay, even whales will come to catch because all of the fish species, school of fish will be present here. A group of fish counting more numbers, n number of fish will be moving as a group. So assured source of fish catch for bigger fish even. By this way, corals are rich in biodiversity. Your mouse pointer now only visible, sir. Okay. Now only visible. Okay, man. So see here. So diversity, various, all of the ocean aquatic organisms, all of the organisms will be present here. This thing we have seen in a tropical rainforest, right, sir? In tropical rainforest biome only, we will witness higher biodiversity because the energy is higher there. In the same manner, all types of algae are present here along with polyps. So all of the aquatic organism will come to this. That's why corals are called as tropical rainforest of the ocean. They are popularly called as tropical rainforest of the ocean. As like tropical rainforest, in ocean we have a tropical rainforest. That is nothing but the corals. Okay, sir. So they are rich in biodiversity. Higher biodiversity is registered in a coral. Wherever I am having corals, the biodiversity is very higher. Understand, sir? So if sediment is coming continuously, the algae will be detached. So mostly they prefer to grow in the fringing area. Fringing means in the edges of the continental shelf. Then only the sediments will settle here. They won't go and attack or hit this coral polyps. So instead of growing very luxuriantly, towards the land mass, they prefer to grow away from the land mass, that is towards the sea. This is a general area. The corals prefer to grow towards the sea and not towards the land. Because if it is facing the land completely, there will be more of sediment deposits. Sir, even the sunscreen lotion which are being used by the, and they get into shallow ocean, the ocean benzone chemical present in the ocean is also affecting this. Yes, sir, surely, sir. Sir, recent days, what we are using in our face wash. Okay, if you find a face wash lotion, you can find some glittering granules, sir. Have you ever noticed, sir, in a face wash? In face wash, you can find some smaller granules. These granules are microbeads. They are called as microbeads. Yes. Okay, these microbeads, after we do face wash, they will reach the ocean only. Okay, they have to reach any aquatic ecosystem. Even recent days in toothpaste, the worrisome thing is we are finding some granules, sir. Okay, these granules, they are micros, they are very, very smaller in nature, and they will reach the ocean ecosystem and they will result in polluting the aquatic ecosystem. Sediments, they are micro sediments. So have it in mind, corals prefer to grow towards the ocean, not towards the land mass. These are the things, sir. So based on the place where we will finish it, sir. We will finish within 5 minutes. Based on the place where they are growing, we can classify as fringing reef. I told, so this is continental shelf. They try to go in the fringes, at the edges. That is, fringing means at the edges, at the periphery. This is a popular type of coral, fringing reef. A fringing reef is a reef that forms around a landmass at the edges, right, sir? This is a popular type of coral, fringing reef. Whereas, see here in this diagram, okay, this is the terrestrial, this is the land mass, and this is ocean water. Okay, sir. This is land mass. So the corals will grow parallelly. Understand, sir? Here there is land mass. The wave action will be up to this. Okay, sir. It's a calm zone, somewhat. So the corals will prefer to grow in a parallel manner along the coast. Okay, wherever the coast is extending, it evenly grow along the coast in a parallel fashion. Sometimes there may be gap between this coral growth, with gaps or without gaps. Now there is very less chance this waterway may mix with the main ocean, right, sir? I can tell the ocean water is trapped here, right, sir? As like a lake. This is called as lagoon. The trapped water between the coral and the coast. Lagoons, right, sir? So this kind of reefs is called as barrier reef. It forms a barrier between the coast. Okay, sir. A single long stretch. Barrier reef. Queensland barrier reef in Australia, right, sir? Barrier reef. So if there is a gap between this coral, if a ship is coming here, okay, the water is very calm here. So naturally it will be used as a harbor. Since water is entrapped here as a lagoon, it acts as a natural harbor. Okay, sir. So this is barrier reef. Whereas atolls, more or less circular corals. You see this diagram. Okay, here there are coral reefs. The reefs will emerge. See, this is ocean water. From base only the corals is growing, not from the deep of the ocean. Okay, corals, one over the another polyp, the reefs are being built up. The skeleton is being added. Along with that, algae is being deposited. Like this manner, the reef will reach even up to the topmost layer of the ocean. Understand, sir? This thing will happen in a circular fashion. This reef building process will happen in a circular fashion with the base of the polyps present in the lower area. Okay, sir. Now, as like I will get a lagoon here, here also there is a chance of getting a lake. Sometimes if If it is completely enclosed without any gap, there is no gap. Okay, corals have built the reef completely as like a basin. Now the wind action will bring the soil and they will get settled here. Soil sediments will be settled here. Now there is even chance for getting collected the rainfall water here. It may be even a pure water lake, right, sir? In rare cases, this will happen in atolls. Mostly there will be some gap. So what's that? Ocean water will intrude here. So it will become a saline water. If a coral is somewhat raised here from the ocean level, there is a chance that there may be fresh water collected from rainfall. So that's why you can find various tree species, even coconut tree species growing here, various kind of trees, as like an island it looks like. Maldives, right, sir? So have it in mind, circular corals are called as atolls. You can find vegetation growth here with more of biodiversity underneath, even biodiversity present over the layer of the corals. Understand, sir? These are the types of coral reefs, sir. So coral reef for food web, it has a, if I'm telling something as biodiversity, obviously there will be food web. See what are the types of consumers present here. Some detritus organisms, coral fishes, sea stars, crabs. Okay, sir. Decomposition will be taking place. So we stop here, sir. So what we are discussing today, we started from aquatic ecosystem. We saw about the zonation. Okay. So we classified organism based on the presence, where based on the limitation. If it is present in the topmost layer, that is in the air-water interface, it is called as new storm. They are free-floating organisms. Then periphyton, they are submerged. In submerged plant, they are glitching organisms. They are attached with the submerged plant species. They are called as periphyton. And plankton, they are the producers. Fourth one, necton, they are the free swimmers. In plankton, we have discussed something about based on the number of flagella. If one single flagella is present, it is called as monotrichous. Bitrichous, if it is two flagella. Amphitrichous, many number of flagella. Lopotrichous, if a tuft of flagella is present, right? And again about the pigmentation of the algae, which is responsible for the color. Erythrophyceae, red algae. Phaeophyceae, brown algae. Xanthophyceae, that is yellow algae, right, sir? Cyanophyceae is blue algae. So photic zone, up to photic zone only zone of production is limited. Production zone is photic zone. In benthos, it is decomposition zone. Abyssal plain in marine ecosystem. Then what's the pelagic zone in marine ecosystem? Along with that, neritic zone. Then we discussed about eutrophication, the external source of excessive addition of nutrient into an aquatic ecosystem. See here, sir. There is no gap for sunlight to penetrate inside. The entire area is slimy algae. This is a neurotoxin condition. This is not algal bloom. After algal bloom, see how much slimy this algae is. It is a neurotoxin condition. So excessive source of external nutrient addition into an aquatic ecosystem. The production phase will be higher compared to consumption phase. The organism present here can't consume. That is the level of the production. So algal mat will be formed. The entry of the sunlight is arrested. So atmospheric oxygen can't enter here. So biological oxygen demand will increase. All of a sudden there will be death of the organisms. Decomposition is partial. Neurotoxins will be released. The entire ecosystem is collapsed. Over a period of time, evaporation still continues. So there will be reduction in water level. At the last stage, what happens? Conversion of a productive aquatic ecosystem to unproductive terrestrial ecosystem, right, sir? These things we discuss. Then bioaccumulation and biomagnification. Entry level is bioaccumulation. Biomagnification, increasing the level of concentration of chemical when it is moving from one trophic level to another trophic level. The topmost organism will be reaching the death status because the concentration is that much fatal when it is moving the topmost what's that level, trophic level. Then mangroves, about the root adaptation for respiration purpose, it is aerial roots. called as pneumatophores. It is negative geotrophic, whereas prop roots, they emerge vertically. Okay, and stilt roots, they emerge laterally. These are anchorage roots. These spores are for extra anchorage. And coppicing, when the main trunk is cut off, new offshoots emerge. This is coppicing. Viviparity, giving birth to young ones as like human, still attached with the mother. Okay, sir. Then how do they know that when they have to release the young ones, sir? So we are delivered out of our mother's action of the baby action, sir. So we are delivered by a combined action. That is the impulse, the baby present inside the mother's womb. It will send impulses to the mother that I am ready. It is called as fetal impulse, right, sir? I am ready, mom. My gestation period is over. I can survive outside now, right, sir? After that, some impulse will start in mother. This impulse, both will work accordingly. Okay, sir. Afterwards, only parturition, kind of signal, right, sir? Impulse will be sent, then oxytocin will be produced naturally in a female body, oxytocin, that will induces the delivery process. So we are developed animals, so we are having these kind of mechanism. Here, yesterday I told something about abscisic acid, right, sir? Premature detachment. So something may happen by release of more of abscisic acid here. In this twig, it may get dried and it will fall off. Can I tell that even plants is having some consciousness? They are having some senses. This is a proof. This is called as viviparity. Okay, sir. Then the benefits we discussed in detail. Nipah fruticans for alcohol production. Rest of the thing will, corals we discussed. Okay, it is a symbiotic relationship between algae and a polyp. The polyps are as such colorless. They are shell forming organism, skeleton forming organism. When algae is coming in association, it becomes symbiotic relationship, higher biodiversity. Coral bleaching is loss of color of the polyps. They will retain the original color. Okay, rest of the things we'll discuss in coming classes, sir. Any doubts do you have, sir? Yes, sir, I will come in next class, sir. Any other doubts, sir? Any other doubts, sir? I made a simple note about COD. I will deal in relation with coliform index tomorrow. Any other doubts, sir? Okay, sir. Thank you. Thank you. Thank you. Thank you, sir. Thank you. Thank you. Take care, sir. Thank you. Thank you, sir. Thank you, sir. Thank you, everyone. Thank you, everyone. Thank you, sir. Thank you so much, Uday. Thank you so much. Sir, if I'm going in a faster manner, kindly intimate me. If you have any doubts, kindly stop me then and there. Okay. Thank you, sir. Thank you. Thank you. Thank you, Nikki. Thank you, sir. Thank you. Thank you. Take care. Thank you.